Number 33 from the review sheet. It says a 5.7, so already I have a bunch of different values. So what I need to do is I need to start writing them in my given. So it says a 5.7 microcoulomb charge is on the x-axis. So I'm going to call that Q1. And a 60 times 10 to the negative 9 coulomb, oh, I'm reading the wrong problem, is that x is equal to negative 3 meters. So what I want to do is I want to start drawing my picture before I get confused. So I'm just doing this. This is my x and y axis. So this is x, this is y, and they tell me that this first charge is Q1 is over here. This is Q1, and I know that this distance here is equal to negative 3 meters. It's negative 3 because here's my frame of reference. So the distance here is actually 3 meters. The negative means that it's that way. Then it says a 2 microcoulomb charge, so I'm going to call that one Q2. And you notice I already, instead of writing micro, I wrote times 10 to the negative 6. Now, obviously, the prefixes that we're using in the homework, micro, nano, do you think you're going to have to know those prefixes for the test since the same ones are being used over and over again? Yeah. And this one is also on the x-axis at 1 meter. So Q2 is going to be over here, and then this distance here is 1 meter. And then it says determine the net electric field on the y-axis at 2 meters. So now up here at this point, we want to find the electric field that's influenced here and here. So basically what happens is I have an electric field that is influencing this point. So that one, this is positive. The electric field always goes in or out of positive? Out. So instead of drawing it this way, I'm going to draw it this way, and this is E1. So I just kind of did an imaginary line, but at this point it's going that way. Then I'm going to see this charge on the point. This one's also positive, so E2 is going to go this way. Again, another imaginary line. And then when it says find the net electric field, the net electric field is really going to be what I'll call E total. All I really have to do is find E1 and E2 and then find the resultant. Now this is not a right triangle. What I would do is I would use law of cosines and law of sines, but we won't do it that way. We're going to do it the same way that we've done it all along. We'll do our table. So first I have to say to myself, what's the equation for electric field? So E is equal to KQ over R squared. So what I'm going to do is I'm going to calculate E1, and then I'm going to calculate E2. So E1 is equal to K Q1 over R1 squared. Now the problem is, if you look at the diagram, the distance between Q1 and this point, that's R1. Do I know what that distance is? No. What I do know is I know this is 3 and I know this is 2. Can I find this distance then? What shape is this? A right triangle. So I'm going to do this off to the side. This is a right triangle. This is 3, this is 2, this would be R1. So the way I would do that is I'd say R1 is equal to the square root of 3 squared plus 2 squared, so R1 comes out to be 3.6. So that's where that comes from. So now this is going to be 9 times 10 to the 9 Newton meter squared per Coulomb squared times Q1, which is 5.7 times 10 to the negative 6 coulombs, divided by R1, which is 3.6 squared. And I got the 3.6 because I had to know some geometry there. So when I do all this on my calculator, this comes out to be 3.9 times 10 to the 3 newtons per coulomb. Now I'm going to do the same thing with E2. E2 is equal to K Q2 over R2 squared. Now what's R2? Well, I have another triangle here. I know this is 1 and this is 2. Can I find the hypotenuse? So I'll do that little one to the side. Here's my right triangle. This is R2. This is 1 and this is 2. So R2 is equal to the square root of 1 squared plus 2 squared. So R2 comes out to be 2.2. So now I'll substitute it in my equation. 9 times 10 to the 9 Newton meter squared per Coulomb squared times 2.0 times 10 to the negative 6 coulombs divided by 2.2 meters squared. So this comes out to be 3.7 times 10 to the 3 newtons per coulomb. But remember, I want to find the net electric force. So when I look at them, remember, if I look at the picture I have up here, this is E2 and this is E1. Whoops. So what I really want to do is I want to find the components of each one. So remember, this is E2x, this is E2y, this is going to be E1x, and that's going to be E1y. Remember, whenever I have any vector, I can find the horizontal and vertical components of that vector. Now my suggestion is to make a table, because we've been doing tables, and tables have helped us to stay organized. So what do I mean? E, X, Y, E1, E2, and E total. So if I have a table like this, and now I look at my chart, first of all, I see that, again, I need to find the horizontal and vertical components of these. So I can start with E1 or E2, it doesn't matter. So E1x, which is over here, is going to be E1 times, I need to find this angle. So there's a bunch of ways you can do it, because we've been doing everything with like sine, cosine, and tangent. What I would do is, I would say, well, what is this angle? And there's easier ways to do it. So if I look at this triangle, I already know that E1x, all I have to do is find, I know that this is, when we looked at this similar triangle here, we knew that this is 3, and we knew that this is 2. So when I have my right triangle here, and this is 3, and this is 2, if I wanted this angle theta, I would say tan of theta is equal to opposite over adjacent, and tan of theta is equal to 2 over 3, so theta comes out to be 34 degrees. So that angle's 34. So E1 is equal to, E1x is E1 times cosine of 34 degrees. So E1x comes out to be 3.2 times 10 to the third. So now I would put that in here. So E1x Then I would do the same thing. E1y is equal to E1 times the sine of 34. So E1y is equal to 2.2 times 10 to the third. So then I would put that in my chart. Now I'm going to do the same thing for E2. So here's E2. So remember, this is E2, E2x and E2y. I need to find this angle. Remember, if I look back at the chart, this side was 1, this side was 2. So I can say tan of theta is opposite over hypotenuse. Remember, these are similar triangles. So tan of theta is equal to 2 divided by 1. So theta comes out to be 63 degrees. So now when I do the math, and I'll do it on the bottom, I'll say E2x is equal to E2 cosine of 63, which is 1.7 times 10 to the third, and E2y is equal to E2 sine of 63, which is 3.3 times 10 to the third. So I put all that in my table. So E2x is 1.7 times 10 to the third, and E2y is 3.3 times 10 to the third. So first, I have to find EX total. So I add up the two x's. So these two I'm going to add up. I'm going to say 3.2 times 10 to the third plus, now if I look at my picture, E2x goes to the left. According to my sign convention, left is what? Negative. We're still using, this is our frame of reference. We're using our same standard Cartesian sign convention. So this is going to be negative, and it makes sense. Look at my picture. See how E2x goes to the left? So when I add this up, negative 1.7 times 10 to the third, E total x is 1.5 times 10 to the 3. Now I do the same thing for EY total. So that's going to be E1y plus E2y. So that's going to be 2.2 times 10 to the third plus 3.3 times 10 to the third, which is 5.5 times 10 to the third. We're getting there. We're almost done. Now, remember, these are the components. So to find the resultant, how am I going to draw it? Well, to find E total, first I'm going to do, here's E total x. From the head of this vector, I do the tail of the other. E total y. From where did I start to where I end up, that's going to be E total. So now, I know the two sides of the right triangle. How do I find the resultant? Pythagorean theorem. So E total is equal to the square root of E total x squared plus E total y squared, which is going to be equal to the square root of 1.5 times 10 to the 3 squared plus 5.5 times 10 to the 3 squared. So E total is 5.7 times 10 to the third newtons per coulomb, but I'm not done. Why aren't I done? I need my direction. So my direction is the angle. So tan theta is equal to opposite over adjacent. So 5.5 times 10 to the third over 1.5 times 10 to the third. So theta comes out to be 75 degrees. Now, what's my frame of reference here? Well, that's the positive x-axis. So a 75 degrees counterclockwise from the positive x-axis, and that's my final answer. And we see that The only physics that we're doing in the problem goes all the way back to the beginning. The only physics in this problem is this equation here. That's the physics. The rest is that we know that we want to find the net electric field. And the electric field is a vector quantity. It has both magnitude and direction. So again, there's no shortcuts to doing this. Who can do this in their head? Nobody. Okay? What you have to do is you have to draw your picture, and you do it step by step. You really can't take shortcuts to doing this. And again, the rest is just math. We're using over and over again math, Pythagorean theorem, definition of tangent. So besides the equation for the electric field, the only other thing from physics is that we know we have to add vectors head to tail, but that's actually math. Knowing that vectors are added vectorially, not algebraically.